Sir,
I
your
will,
screen is not visible, sir.
I will ask you, design a network for a small company. Design a small network for a company. See what I am expecting. You guys are beginner, fresher. All are fresher. Abhi Shankar, what about you? And we need to cover entire switching protocols in 3 to 4 classes. Entire switching we need to cover today, tomorrow, classes we are going to. So in switching, first of all, you should have knowledge about the meaning of switching. What is the meaning of switching?
Transferring packet from one interface to another interface.
Before switching, what is switch?
Layer 2 device transfer packets based on MAC table.
Can be layer 2 or layer 3.
Yeah, it is layer
Let's talk about layer 2. So layer 2 switch forward traffic on the basis of
MAC table.
MAC address table, right? And how switch build MAC address table? I will talk about basic 3 functions of switch. Basic 3 functions of. First one is address learning. You have knowledge about address learning, that how switch is learning address. How switch is learning address. Address learning. You all know the routing, right? All already know the routing. Switching, first thing is switch, and there are three basic functions of switch. First one is address learning, second one is forwarding the traffic, and the third thing is loop avoidance. Loop avoidance. These are three basic functions of switch that every switch perform. Each and every switches perform these three functions. First one is address learning, switch is going to learn address. Now question, how switch will learn address? How switch will learn address? Source. With the help of source, you know the concept is very simple. Whenever switch will receive any frame on their interface, it is going to learn source MAC address. It is going to learn source MAC address. It will make one entry in their MAC address table. Guys, in the MAC address table, what will be the information? What are the information carried by switch in MAC address table?
VLAN ID,
MAC
MAC
address.
address, type.
The most important thing is MAC address itself. Then VLAN information, and the last thing is interface ID. Interface ID. So everything is there. VLAN means, what is VLAN? What do you mean by
Virtual,
VLAN? Virtual local
virtual.
area network?
Yeah.
What it is? Why we are using it?
To by default, switch can have only one broadcast domain. By using VLAN, we can segregate multiple broadcast domains.
Break the
So that
broadcast
is domain.
domain on switch. Now question is, why we need to break the broadcast domain? Question, why we need to break broadcast domain?
Uh, to minimize the CPU utilization, to minimize the bandwidth.
Broadcast. And what is broadcast domain? Two questions are there. One is, what is broadcast domain? Another one is, what is the benefit of dividing broadcast domain? Why we break single broadcast domain into multiple parts? So you said,
The,
yes.
the area where broadcast messages were travel will be the
Yes.
broadcast domain.
Domain where broadcast message can be table is known as broadcast domain, And now why we need to divide a broadcast domain?
To reduce the flood of broadcast
To
and to
reduce
minimize
the CPU
utilization.
uses. Yes, CPU uses work. Second, to implement security. Third, to implement quality of service. QoS, quality of service. I am expecting you have basic idea about the quality of service. Quality of service means prioritizing traffic, forwarding critical traffic first, mission critical traffic first, the network. Means logically we can say this is a process to tell our devices to forward this traffic first, because this is a business critical traffic, mission critical traffic, right? Then to separate different types of traffic, to separate different types of traffic. Let's say in the network there are multiple departments: HR department, right, finance department, sales departments, and for an example, admin department. So there are 4 departments in the company. So if we are going to connect these all departments through the switch, through layer 2 switch, that means by default all the departments, all the users belongs to single broadcast domain, right? And with the help of VLAN we can separate each department. So let's talk about network designing first. If you need to design a network for a company, you are the network engineer in a company where you need to design one network in the enterprise company. Should I tell you the requirement? Let's say here I am writing the requirement. Require of a corporate company, right? So let's say we can say in ABC company there are 200 users in each department each department, and there are how many department, and there are 4 departments. First thing, so as a network engineer you need to connect all the users with each other. We need to connect all the user with each other. So how we are connecting multiple networking devices, guys? Through layer 2 switch. Through layer 2 switch. Now in each department we can have end users, means PCs, we can have servers, we can have printers, we can have IoT devices, we can have access point, we can have any other end devices, servers, and we are going to connect them all together through layer 2, right? So at the same time here I am designing the network also. For an example, this is a PC, this is a server, the access point, this is a printer, right? Like this, in each department we have these end devices. And to connect these all devices I can have lots of access layer switches. Now let's say on one access layer switch I have 24 ports. 24 ports are there on one switch. And how many devices I can connect here? Hardly you can connect 23 devices. But guys, how many users are there in each department? How many users are there in each department? 200. So you need multiple switches. You need multiple switches. If I am going to add one more switch here, let's say 2 switch. But now I need to connect these 2 switches together also. I need to connect these 2 switches together also by using Ethernet cable. Let's say I have used one Ethernet cable. Now still there is issue. What if this link will goes down? Right? Or the another thing is, what is the bandwidth of this link? If this is a fast Ethernet link, then bandwidth is 100 Mbps over here. Bandwidth is 100 Mbps. So all 24 users are going to share this 100 Mbps bandwidth. Each will get around 4 Mbps bandwidth only. So if I need more bandwidth between switch, what I can do? I can add one more link here. But if you will add one more link here, then you are going to learn in a spanning tree protocol or loop can form, and STP will block one port. Then you are going to bundle these 2 ports in EtherChannel. So if you are bundling it in EtherChannel, then that means you have utilized 2 ports on switch for interconnectivity. How many ports are available for users? 22. 22 ports are available for you guys. Like this, I have another switch here also, and here also I am going to add 2 link. But now see, on switch number 2 I have only how many? 3 ports. I have only 20 free. Right? So this is not the solution to increase the number of ports at access here. We have one different technology over here that we are using called stacking. Stacking, right? So what is stacking? Stacking is nothing but the method to combine, to bundle multiple physical switch into single logical switch, right? One switch have 24 ports. If I am going to combine 4 switches here logically, then how many port I will have on single switch? 24, 24, 24 and 24. 8 times 24 means how many ports are there now? 96. 96 ports are there now. If I am going to bundle 8 devices, then I can fulfill my requirement. Around I will have 200 ports, and then I am going to connect these all devices. Here also, for an example, these switches are in stack. Now guys, tell me, can these all users communicate with each other? Can these all users communicate with each other? Yes or no?
Yes.
No. Because there is no connectivity between switches. Switch 1, this is switch 2. So user sitting connected to switch number 1 cannot communicate with user connected to switch number 2. Right? Now how we are going to provide connectivity between the switches? So always keep in mind, we'll never connect access layer switches together. We'll not connect switches like this. And how we are going to connect the switch? We are going to integrate here one more layer. Right? I will talk about Cisco network design architecture. So there are, according to Cisco network architecture, there are 3 layers. There are 2 design. 2 common designs are there. One is 3-tier architecture, and another one is 2-tier architecture. Here architecture. In 2-tier architecture, you will have 2 layers. In 3-tier architecture, you will have 3 layers. For an example, see this network. My screen visible?
Yes.
So what I am doing here, guys, same thing. This is network of a company. This is a real network. real network of a company. Let's say XYZ company or ABC company. And these are the end users. These are the end users, endpoints, end users. How these all end users are connected? Even here I have access point also for wireless connectivity. If there are some wireless clients, so they can also access network resources through access point. See, all the end devices are connected through layer 2 switch. Now there are four types of traffic. What I told you: HR, finance, then admin, and there was one more department. Let's say networking. And on switch number, let's say this switch on switch number 1, there are some user belongs to HR department, some user belongs to finance department, some user belongs to admin department, some user belongs to networking department. How we are going to separate the traffic? With the help of VLAN. So on access layer switches, what we are going to do first, we are going to create how many VLAN? 4 VLAN should be there in the VLAN database on all access layer. And we are going to place correct devices in correct VLAN. Like let's say this PC, this host belongs to admin department, and for admin I am using VLAN 10. So this PC will be in which VLAN? This PC will be in VLAN 10. This PC is going to be in VLAN 10. If this PC also belongs to admin department only, this is also part of VLAN 10. So how these two devices can communicate? These two devices can communicate through distribution layer, right? In the this is 3-tier architecture. This is layer 2 access layer, this is distribution layer, and this is my core layer. Distribution layer is responsible for distributing the traffic over multiple access layer switches. So this is first and basic part of an enterprise network. I'm talking about this access layer. First of all, you need to configure access layer here only. Then what will be the gateway? Where is the gateway profile for VLAN 10 users or 20 users? So gateway is nothing but the distribution. Here we are going to create gateway. And whatever policies you need to configure in the network. Policies means, for an example, this department or admin department should be able to communicate with finance department, but should not be able to communicate with admin department. This is what one kind of policy. Or the finance department should have limited access of internet. Should be only able to access, let's say, google.com, Google homepage. This department user should not be able to access Facebook. So these are what? These are my policy. Where we will implement these policies on distribution layer. And between distribution and layer and access layer, I have lots of link. So in the last class, what we have seen? Encapsulation protocol, trunking. So all these links are going to carry traffic of multiple VLAN, right? Guys, these all links are going to carry traffic of multiple VLAN. Am I right? So these ports should be trunk port. There are two types of switch port. Remember, first one is access port and second one is trunk port. What is access port?
Can carry single VLAN.
Can carry single VLAN traffic. And what is trunk port?
Can handle multiple VLAN traffic.
Multiple VLAN traffic by default, which carry all VLANs traffic. Right? So all the ports which are connected to end users will be your access port, and all the links between switches will be trunk port. Apart from this, here in this design, you can see few more things. At core layer, I have integrated the internet also. Here I have internet access so that my end devices can access internet. There is one server room, maybe where company is hosting some application. there are some network services, right? Maybe you are not familiar with these services. ICE is there, access server is there, WLC is there. Through WLC, you know, we are managing multiple access points. And then here we have WAN 6, from where we can connect other sites. Like this, I have another site somewhere, let's say in US, and this is in India. So from this section, we are going to connect multiple sites together. So this is going to be your enterprise network. This is just one side of a company, right? So how many things you need to learn here? Routing, first of all, for this section. Routing. Again, in the routing, there are many things. Best path selection, path manipulation, load balancing, everything we can implement over here. And in this section, you need to learn switching protocol. So mainly we are going to focus over here in this section today. Clear? Mainly we are going to focus on this section. Okay, guys. So this is my requirement. Now you know how we are going to connect these all department to. Now your second requirement is going to be all the department, all the department should be able to communicate with other. All the departments should be able to communicate with. After implementing the layer 2 protocols, all the departments should be able to communicate. There will be reachability, right? For how two departments are going to communicate with the help of gateway. So gateway is required. You have to configure gateway, right? And for the gateway on the distribution layer switch, we are going to create what? SVI. Anyone have idea about SVI? What is SVI?
A switch virtual interface.
Switch virtual. What it is? This is a virtual interface on switch. Virtual interface on. So in this case, for all four types of VLAN, we are going to create SVI on distribution layer. I will show you the implementation as well, right? So here SVI is required, here VLAN is required, right? And then your third requirement is going to be all the department should be able to access the. So here you are going to now configure edge technology. And then your requirement can be all the sides, all the branches should be able to communicate with each other. In that case, you will configure VPN, right? So let's implement everything over here. I'm going to design one very simple network for you. Your network designing is always going to be like this, or here. your network. Okay. This way you are going to connect access layer and switch distribution here, or either in here also you can see same design for the LAN. Similar way we are designing the network, and here only you need to learn how to implement switching protocol and how to implement routing. Here you will have end devices, all the users connected to access layer, all the access layer switches are connected to distribution layer, and distribution layer is connected to core.
Yes.
Dummy devices, then will implement all the protocols over here. The devices are already configured. Well, so IP brief. You can see this is phrase top. Guys, you know the DHCP? DHCP, how many of you know the DHCP?
Uh, I know just the procedure.
So see the requirement, this is a network of data center of XYZ company. There are 4 departments. So I have how many access layer switches? 4, and you can see I have 4 VLANs. VLAN 10, 20, 30, 40. Around 200 users are there in each department. So what should be my slash value? Is what should be the slash value, CIDR value? If I need 200 IP
How many
addresses,
users, sir?
200 users are there. Department.
Uh, for 24.
Slash
Sir,
24.
24.
Yes. Slash 24, we will have 254 valid IP addresses, correct? And here are the requirement of configuration. You need to set up DHCP so that end devices can get IP address. You need to configure VLAN. You also need to configure switch port protected. Switch port protected is one feature on Cisco switch, right? I will tell you about this feature also. You need to configure inter VLAN routing. What is the meaning of inter VLAN routing?
We can communicate
Routing
between
between
different VLAN.
two or more
VLAN.
different VLANs.
Yes, sir.
Then you need to configure gateway, HSRP, OSP, UpNet, SLA, SPAN, STP, EtherChannel, and trunk port. Let's begin the configuration from access layer. So guys, first of all, tell me on access layer switch 1, I am going to configure access layer switch 1, and I am going to write the command in notepad so that later I can share with you. On access layer switch 1, enable config D, then 4 VLAN I need to create. VLAN 10, exit. VLAN 20, exit. VLAN 30, exit. And VLAN 40. Right, we can give name as well here. Name, you can say HR. Here we can say name, sales. Here we can give name admin. Here we can give What?
Sir,
Yes, yes.
in switch 1, the VLAN 30 and 40 is not there. But why we need to create VLAN 30 and
So
40?
that this switch can process the traffic. Let's say VLAN 30 is not there.
Yes, sir.
Switch 1, switch 2, and switch 3. There are 3 switches. Here I have one user in VLAN 10. Here I have one user in VLAN 10. Done. So guys, can this PC communicate with this PC if VLAN 10 does not exist in the VLAN database of switch 2?
Yeah, no, sir.
No, neighbor. It cannot process the traffic of VLAN 10. So that's why VLAN database should be what? Identical on all the switches. It should be same. VLAN data should be synchronized so that it can process. Whenever switch 2 will have traffic for VLAN 10, let's say this user is going to ping VLAN 10 user. So if VLAN 10 does not exist over here, it cannot process the traffic.
Yes, sir. Okay.
So VLAN must be there in the VLAN database of all the switches. That's why I have one protocol called VTP.
VTP.
VTP stands for VLAN trunking protocol. VTP is used to synchronize the VLAN database, right? Let's say here in this scenario, I have enabled the VTP on all the switches and I am going to create VLAN on any one switch. Automatically it will propagate the VLAN information. Let me do one thing. Let me configure VTP over here, right, for the VLAN propagation. I'm not going to create these all VLAN on all the switches. Okay, but guys, there are some requirement of VTP. May I know the requirement of VTP?
Yes, sir. Domain name must be same.
Domain
Version
name must be
same.
same.
Version number must be same.
Okay,
Password must be same.
okay. I am not going to configure the version. I am not going to configure the password. Then link between switches must be configured as
Trunk.
trunk, right? So for the VTP, first of all, here I have to configure these all links as trunk link. I have to configure these all links as trunk. And again, to configure to form trunking between switches, I have one protocol. Again, 2 methods are there. One is manual. Manually we can configure the trunk port, or we can use a protocol called DTP. DTP stands for
Dynamic.
dynamic trunk. What is the requirement of DTP? Guys, can anyone tell me what is the by default administrative mode of switch port? Switch port. You know, on switch port, I have 2 types of
Yes.
mode.
Access.
No, that is operational mode. Administrative mode plus operational mode. What is administrative mode? What is administrative mode and what is operational mode? Last class also you have seen this, so that's why I'm expecting answer from you. Tell me, just I am coming.
So do you know that?
Yeah, no, but not in deeply.
I do not know.
Yes. Tell me.
Administrative mode is the mode uh, we manually set.
Which admin have configure on the switch port?
switch port, and operational mode, that how the
Admin config we can say here, right?
yeah,
Admin configuration. And operational mode is
how this actually work.
output of admin configuration,
Yes, sir.
right? So operational mode can be either access port or it can be trunk port. There are only two types of switch port. Either it can be access or it can be trunk. But admin can configure either a static access, a static trunk, and there are two modes of,
Dynamic auto.
these are modes of DTP: dynamic, auto, and dynamic
Desirable.
desirable. By default, admin mode is dynamic auto. By default, admin mode is dynamic auto. You can verify it also. How we can verify it? How I can verify the admin mode?
In interface mode.
On any switch, we can run command. So interface, then interface type, then switch port.
Yes, sir.
So interface, let's say E0/1, 1, and then we can say what switch.
Switch
So you can see what is administrative mode over here. Administrative mode is dynamic
dynamic.
auto, and operational mode is access. Operational mode is static access. And guys, in the DTP we have seen there are two modes. One is dynamic auto and second one is dynamic desirable, right? So let's talk about two switch. I have two switch 1 and switch 2. By default, mode over here is administrative mode is dynamic auto, and here also dynamic auto, right? So will trunking form between switch 1 or switch 2?
No.
Because dynamic auto and dynamic auto can never form trunking,
Trunk.
right? But if I will make this port as dynamic desirable, will trunking form?
Yes.
Yes,
Yeah.
right? Dynamic desirable and dynamic auto always form trunking, or dynamic desirable and dynamic auto can also form trunking, or dynamic desirable and dynamic desirable can also form trunking. So there is only one case of DTP where trunking will not form, that is if mode is dynamic auto both side. If the mode is dynamic auto both side, then trunking will not form, and this is the by default mode of DTP. So if I want to configure these all ports as trunk port, or we can say these all links as trunk link, so what I can do here, I can select these interfaces and I can say switch port mode dynamic desirable. Here mode is dynamic auto, automatically trunking will form. Yes or no?
Yes, sir.
Yes, right? So here you can verify the trunk link on switch 1. I'm going to run command. So interface trunk. So you can see there is no any trunk link. There is no any trunk link. So I have two options. Manually I can run switch port mode trunk, switch port trunk encapsulation .1Q. Two commands are required on all the interfaces. Or the another option is I can run this command on distribution layer switch 1 and distribution switch. Getting my point? Just I am fulfilling the requirement of VTP. First requirement trunk. So I am going to form all the links between switches as trunk. Right? So on D switch 1, what command I will run? Interface range E0/0 3. You can see this command is going to select all these interfaces which are connected to access switches, and here I am going to say switch port
Mode,
switch port
mode,
mode
desirable.
mode
Desirable.
desirable. And before configuring desirable, I have to define the encapsulation protocol also. Switch port trunk
And
encapsulation
Dot1Q.
Dot1, then switch port,
Mode disable.
port dynamic variable, port, and I need to run same command on switch number 2 also. So let me copy these two commands and I am going to paste it on both the switch distribution switch 1 as well as distribution switch. Copy. You can see all the commands are accepted, and after that, after running this command, you can verify the trunk on access. Earlier I had run same command, show interface trunk, but in the output I was not able to see anything. This time you can see. This time you can see which port is the trunk port. 0/2, which is connected to distribution switch 1. Correct?
Yes, sir.
Now I am going to run these two command on distribution switch. Enable config tree, and now I am expecting all the link between switches are configured as trunk. Here you can see both the ports are trunk port. Why here it's saying none? So a span tree. In a span tree, you will not need the 0/3 interface. 0/3 interface is alternate. Right? It is in blocking state. Because of a span tree protocol, this port is in blocking state. You will not need it in STP. Clear till here? Now all the links
Yes.
are trunk link between switches. Now guys, the next thing is VTP domain name. We need to configure VTP domain name on all the switches. So VTP, another command to configure VTP domain name. VTP.
No, sir, don't know.
So I need to run this command on all the switches for VTP on access layer switch 1. What it's saying, name is already Cisco. So VTP is already there on any switch and any other switch also we can verify the name. So the status you can use to check the domain name. What is domain name over here? Cisco. So VTP domain name is already configured on all the switches. Now this is your question. I want to delete the VTP domain name. What I can do? I want to delete VTP domain name from the switch.
Change the domain name.
So VTP, no, I want to set it on default. So VTP status. Domain name is Cisco. You want to check the running configuration of VTP. Here you can say section and VTP. VTP. Run. VTP. Domain. That means on this switch I have not run the command. Maybe on any other switch I have configured the domain name and automatically it will propagate that information also. So run VTP. On any switch we can configure the domain name and it will propagate the VLAN information to the entire VTP domain, right? So in my case VTP domain name is already configured. If you want to configure the password, you can run this command. VTP password, right? And we can say password Cisco. But make sure you, if you have configured the password, then password is same on all the yes. Done. Now let me show you one thing here. Switch 1, access layer switch 1, and so VLAN brief. See, VLAN 10, 20, 30, 40 are already there. Then 10, 20, 30, 40 are already there. From the distribution layer switch 1, so VTP status. Mode server. In VTP there are three types of switches. One is server mode switch, one is client mode switch, and another one is transparent mode switch. There are three modes of switch in VTP: server mode, client mode, and transparent mode. Another one is off mode also. Off mode. So guys, server mode is the switch where you are allowed to create, delete, and modify the VLAN. Client mode switch is the switch where you are not allowed to create, delete, or modify the VLAN. And transparent mode switch is the switch where VLAN database will not be updated through VTP message. On transparent mode switch, manually you can create the VLAN, you can delete the VLAN, you are allowed to modify the VLAN database, but that will not impact in the VTP domain. That will not impact in the VTP domain. Means transparent mode switch never generate VTP message. It can only receive the VTP message and pass to the other switch without updating their own database. And off mode switch means turning off the on the switch, turning on the of the VTP on the. So here on this switch, mode is server. So that's why we are allowed to create, delete, and modify the VLAN. Here I am saying no VLAN 10 to let's say 40. Then 10 40. So what will happen? VLAN is deleted. So VLAN brief, you can see only default VLANs are there now. From the access layer switch 1 also you can check now VLAN database. Now you can see all the VLANs are removed. So guys, if by mistaken someone is going to run no VLAN 10 to 40 commands on this switch, then VLAN will be automatically removed from all the switches. So that's why we have got another mode, client mode. If let's say fresher engineers are connected to this switch, then I will configure mode here is client, so that they cannot remove the VLAN. So that they cannot remove the VLAN. Otherwise, anyone can modify the VLAN from the entire VTP domain. Let's say here you can see the server. This server is in VLAN 40. So now earlier end users as well as outside user, means user from the internet were accessing this server. Now can end users access this server? No, because VLAN 40 is removed from the switch. Another thing over here, what we can do? See, if you want to manage the VTP or VLAN database of all the switches from this switch only, then you can configure mode of this switch as server mode, and mode of rest all switches is going to be client mode. Means on any other switches we are not allowed to modify the VLAN database. We are only allowed to modify the VLAN database on switch 1, and from here only we are going to manage the entire VLAN database of all the switches. We need to implement these all protocols today. Two, so, three. Guys, there are some more concept of VTP here that you need to run, like the mode. Apart from the mode, configuration revision number. Anyone have idea about configuration revision number?
Yes, sir.
Tell me.
Whenever new database update is available, the revision number will be increased by 1.
Okay.
Switch will accept only the higher revision number.
Which update their database with higher configuration revision number, right? So whenever guys change will occur in the VLAN database, your number will be incremented by 1. Whenever you are going to delete the VLAN, it will be incremented by 1. Whenever you are going to create the VLAN, again it will be incremented by 1. Okay, and whenever switch is going to send VTP update message, how other switch will get to know about the update message is updated or not? With the help of CR number only. Let's say this switch is receiving one VTP update message. So first switch is going to check what is the CR number in the update message. If CR number is 5, that means no, I don't need to check this update message because I have already the database with CR number 5. If switch is receiving update message with CR number 6, that means there are some updated information. Let me check what information. Then updater ID is there. What is updater ID? Updater ID is used to identify from which switch last time I have updated my database. From which switch I have updated my database. Right? So here also you can see the configuration last modified by 0.0.0.0. So I didn't configure any IP address on the switches. That's why the updater ID is 0.0.0. Once I will create the SVI, you will see the IP address on the SVI interface will become updater ID. If there are multiple SVIs, then the highest IP address on SVI interface will become updater ID, and there will be information about which have modified the database for the last time. Okay. Then pruning is there. This is some advanced concept. BTP depths you can for now. Then version is there. 3 versions are there. Version 1, 2, and which version is running on the switch?
Version 1.
Version 1 is here. Here till here. BTP, and then you can put question mark. You can see these are the configuration available over here. NS3. We can set domain name. We can configure interface for the updater ID, for the updater address, right? We can change the mode. We can configure the password. We can enable the pruning, and then we can set the version, right? So if I am going to use mode here, you can see how many options are there. Client mode we can configure, server mode we can configure, transparent mode we can configure, or off mode I can configure. If I will set off mode, what will happen? What it's saying? Setting the device to VTP off mode for VLANs. Now do so VTP mode is off, and guys CR number is right. Now this switch will not participate in VTP domain, right? If I am going to say VTP mode transparent, again this switch will not participate in VTP. It will participate in VTP, but it will not update their own database with the help of VTP message. Port is transparent, CR number is in.
Hello, sir. Am I audible? Hello.
Hello.
Yes, bro.
Your screen has stuck. Okay.
VTP. Can I say no to this command, guys? Will this command work to remove the VTP domain name?
No, sir.
And how to set default domain name? Default domain name is null. Default domain name is null. Right? So I can run this command. What it's saying now? Domain name change to null. And here you can see the log message. Match error. What it's saying? Unable to perform trunk negotiation on port 0/1 because the VTP domain. So here I am again going to say VTP domain name. So link between switches are trunk and domain name is Cisco on all the switches. So if I will create VLAN over here, VLAN will be propagated to all the switches automatically, correct? So let me copy these all commands and let me paste it on this. Now, so VLAN is created and so VTP status. CR number is still 0 because the mode over here is transparent. That's why CR number will be always 0 on transparent mode. So let me make this switch as server. VTP domain name. And see guys, on access layer switch 1, I will not have VLAN in the VLAN database. So VLAN brief. Only default VLANs are there. Right? So transparent mode switch is not going to advertise VLAN information in VTP domain. So VTP mode server. Now so status now again you 5 and on access layer switch 1 can show you VLAN database and it will propagate the VLAN information. I can do one thing. Then what happened? So interface trunk so yes server by VLAN. So it here also when you will change the mode of VTP, automatically VLAN will remove from transparent to server. When you will change mode from transparent to server, then VLAN is going to be removed. So VLAN 10, 20, 30 and 40. This way also we can create the VLAN exit. 2 so VLAN and now on access layer switch 1 here you can All the VLANs are proper. Now on any switch you can verify. Let's say on distribution switch 2. Here also I will have same VLAN database. VLAN database of all the switches is going to be same. So VLAN brief. And guys, here if I am going to set mode client, this switch 1 I am going to set mode client, TP mode client, right? And now if I will try to create VLAN 100 over here, what it's saying? VTP VLAN configuration not allowed when device is in
Client mode.
Client.
so we cannot create then the client mode. Can I move further? VTP is done. DTP is done. What next over? Now we can put the interfaces in VLAN. Let's say here on access switch 1, I am going to configure PC1 in VLAN 10 interface 0/0 port is VLAN and switch port mode access. This command will disable the DTP protocol on the port. Okay. Command is going to put the port in VLAN 10. But guys, this way we are putting the devices in VLAN or we are putting the port of switch in VLAN? My question is, see here in the building there are some floors and at each floors I have some switches and there is one PC. What I want, PC MAC address. I want this PC should be always in VLAN 10. Doesn't matter where I am connecting it. Maybe I am connecting this PC on floor 1 or floor 2 or floor 3. Doesn't matter. This PC should be always in VLAN 10. What I can do? This way, if here I will configure this port in VLAN 10, I will put this port in VLAN 10. That is fine. Now PC1 is in VLAN 10. But later, let's say tomorrow, this PC is going to connect on different switch. On different switch, switch number 2. Here. Maybe this can be in different VLAN. Can be in VLAN 20, 30. That depends on this port. Port is member of which VLAN. So by running command switch port access VLAN 10, we are not putting the PC in VLAN. We are putting interface of switch in VLAN, right?
Yes.
Port this VLAN. So this command is used to assign a switch port in the VLAN, not used to assign a PC in VLAN. Then question is how I can assign PC to VLAN? How I can assign a PC to VLAN? My requirement is this PC should be always in VLAN 10 on. Doesn't matter where I am connecting. Have idea?
MAC address. One more technique is there, like MAC address. Using MAC address.
What is the name of that technique?
No, sir, I do not remember.
Mechanical binding.
Guys, there are two types of VLAN assignment. There are two types of VLAN assignment. There are two methods. One is manual and this is the manual method. And second one is dynamic method. Dynamic. In dynamic, we are going to use one server called VMPS server. VMPS server. So what we'll do here, we'll add one server and on the server, we are going to create one database. The database, there will be information. Let's say this VMPS server IP address is 10.1.1.1. IP address of server. And here I have created the database. In the database, I am going to say PC whose MAC address is A MAC address will be always in VLAN 10. B MAC address will be always in VLAN 20. Always in VLAN 20. And now I am going to tell to switch about the VMPS server. The IP address of VMPS server is 10.1.1.1. Now whenever you are going to connect any device to this switch will first send one request message to VMPS server. Because guys, when I will connect this PC, what will happen? This switch is going to generate some kind of traffic, right? When you will configure IP here, let's say 1.1.1.1, this machine will generate GARP, gracious ARP, to check duplicate IP address. Is it the unique IP address or duplicate? Right, and this is our broadcast, it will forward to switch. On switch will receive the traffic on this port. Let's say this is 0/0 port. It is going to send the request message to server. Hey, I am receiving a traffic with source A. Right, server is going to check the database. In the database there is one entry that A MAC address should be in VLAN 10. So the server is going to send the information to switch, and then switch will automatically put this port in VLAN. So this is dynamic method of assigning port into the VLAN, right? So there are two methods. Here. Now before talking about distribution layer, let's talk about access layer. At access layer, there are some more concept on the access ports. Guys, here what will happen? What will happen if I am going to send some virus this switch? I am the employee in the company, right? What if I will connect my own laptop on this port and then I will start downloading movie? Right? So by default, switch is trusting on everyone. We can connect any PC to any ports of switch. By default, there is no any security, right? The real time here you will be implementing what? Port security. Port security means I know, let's say this is a laptop of company. You are the employee, your name is Aman, right? And company have provided you the laptop. So if company have provided you the laptop, then company can integrate some security as well. This is the only reason why companies are providing their own system to their employees, so that they can implement security. So company know the MAC address of your computer. Let's say MAC address of your computer is A. Company is only going to allow computer whose MAC address is A on this particular port. So now if you are going to connect your own laptop over here on this port, your laptop will have different MAC address. MAC address is globally unique. Automatically switch will shut this port, right? Or maybe switch will put this port in error disable mode. Or maybe this switch will send one log message to the network admin that hey, someone is trying to connect their own laptop with different MAC address. So port security is also layer 2 protocol. Here we are configuring on access ports of the switch. It's not for the trunk link, because on the trunk link we are allowing multiple MAC addresses, but on the access link, access ports will only allow one MAC address, right? So here on this access port we can run one more command, switch port security. This command will enable switch port security. Then we can say switch port security violation, what action it should take. So there are 3 action. First one is protect, second one is restrict, and third one is shut down. These are the mode of port security. So if I am saying shut down, then it will shut the port when it will receive traffic from any other. Then how many MAC address you want to allow on this port? Switch port security, and maximum I can say 1. I want to only allow 1 MAC address, right? If you want to configure the MAC address, you can run this command, switch port security, and then address. MAC. If you want that switch should take MAC address from the MAC address table, then here you can say ST key. ST key is this. Now it will check their MAC address table, and whatever MAC address is learned on this particular port, will be bind on this port. Dynamic binding. Then switch port security, and is there any another option? Phasing is there, MAC address I have done. Right, so this command is also required on the address port. Now I am going to put PC2 in VLAN 20 0/1 0/1. I am going to put port access VLAN. That's it. Here also you will enable the port security. Then go to switch number 2. On switch number 2, so then brief first of all. You can see all the VLANs are there, and I am going to configure this port is in VLAN 20. Interface is /0 port access VLAN. Switch port access port access. Number 3, well, config space is then space is /0 switch port X and 10. Let's say I'm going to put this VLAN 10, and I am going to put server in VLAN 20. Space is /3 port X and server is in VLAN 40 and right. So guys, can PC1 ping to PC4? Can PC1 and PC4 communicate with each other? On PC1, here I am going to configure one IP. What is the subnet for VLAN 10? Here you can see subnet for VLAN 10 is VLAN 40 and 30 and so for VLAN 10 my subnet is 192.168.1.0. I'm going to configure one IP address, let's say .1 over here. IP 192.168.1.1/20, and on PC4 I am going to configure 1.4 IP 192.168.1.4/. Can PC1 ping to PC4? Tell me yes or no at least.
No, sir. No, sir.
Why not?
Because no routing protocol is enabled till now.
Why protocol is required, brother? Not required, no. Protocol is not required. Both
But
belong to same VLAN. Both
the
PC
network.
belongs to same VLAN, VLAN 10.
Okay, then ping is possible.
Right? So ping should work.
Yeah, then it will work.
They need to communicate 192.168 or 1 dot, and you can see ping is working. Right? So now same department users can communicate, like department 1, all the users in department 1 can communicate, all the users in department 2 can communicate, in 3 can communicate, 4 can communicate. But can two different department communicate, guys?
No, sir.
Here on the PC number 3, the PC3 is in VLAN 30, and subnet for VLAN 30 is 192.168.3 dot. Here I am going to configure, let's say 3.3/20. So can I ping PC3 from PC1?
No, sir.
Can 3.3, will this ping work?
No, sir.
What it's saying? Hey brother, you are pinging too the IP address which belongs to different subnet, and whenever you need to ping different subnet, gateway is required, but gateway not found. Gateway is not configured here. Correct?
Yes, sir.
To make communication possible between two different network, gateway is required, right? Now where is the gateway, guys? Where is the gateway? Okay, before making reachability between two subnet, one more thing here I want to discuss. That is, let me, I have two switch. Which one? Switch. There are two links between switch 1 and switch. Switch. Let's say this is interface is interface ID 1, port number 1. Here port number is port number over here is 2. Done. Here is one user. Here is one. Both belongs to, let's say, same VLAN. Both belongs to VLAN. Here I can say here IP address is 10.1. Both belongs to VLAN 10. Or let's say default VLAN, VLAN 1, okay? All the ports belongs to same. Now guys, if I am going to ping PC from PC1, ping 10.1.1.2, you know, to send traffic to 10.2, PC1 need what? MAC address of 10.2, correct? So PC1 is going to check their ARP table. In their ARP table, if MAC address is not available, then what will happen? Then PC1 is going to generate ARP request. In the ARP request, source MAC will be A and destination MAC will be what?
Broadcast.
All F, broadcast, and then PC will forward it to one. Which one will receive it on this interface? After that, it will forward one copy from both the interface, right?
Yes.
When switch 2 will receive this broadcast message on port number 1, will switch 2 forward it from switch port number 2?
Yes.
Right? When switch 1 will receive the broadcast message on port number 2, again it will forward from port 1.
Yes.
So there will be loop.
Yes.
There will be loop. This loop is also called MAC flapping, because let's say for an example, this is port number. So when switch will receive the traffic, first switch is going to learn a MAC address. On which port? On port number 3. And after that it will forward this broadcast message. It will check destination. Have learned the source MAC, then it is going to check destination MAC. Destination MAC is broadcast. It will forward from both the port. Switch is going to learn a MAC address on both the port. On port 1 also, then port 2. So MAC will be flapping over here. Same thing will be happening on switch number 1 also. MAC address will be flapping on port number 1 and 2. And this broadcast message will be between switch 1 and switch 2 like this. That particular thing is called what? Loop. So every time loop will form whenever user will generate broadcast message. Or in case of a non-unicast forwarding also loop will form. True, right? Right.
Yes.
And to avoid this loop, have guys, by default STP is enable or disable on switch?
It is enabled on.
By default it is enabled,
Enabled.
because this protocol is very important. If it is not enabled, then loop will form. So that's why by default STP is enabled. And what STP protocol is going to do? STP protocol is going to create a loop topology. Create a loop 3. STP is responsible to create loop free topology only. Now question is how STP will get loop free topology. Loop free topology means block the one port. I will block this port, then loop will not form. And when this link will goes down, automatically this link will come up. Lower link. Until and unless both links are up, STP will only allow one port in forwarding state. STP will only allow one port in forwarding state between the switches to avoid the loop. If you have different topology, let's say switch 1, 2 and switch 3. Again here also loop can form, yes or no? When loop can form, guys, when we have redundant link in the network. When I have redundant link in the, why I have added 2 link here? For the redundancy. And whenever you are going to add the redundancy, there will be loop. In this case also STP will work, and STP will block any one port. Maybe this port it can block path. So one link will be blocked over here in this scenario. Here is the PC. Here is the PC. So these two PC can communicate like this. But what if this switch will goes down or this link will goes down? So there is no any redundancy. If I am going to add redundancy, then there is issue of. So either I can assign one engineer over here. Let's say on this switch, switch number 3. Hey bro, remove this link. Remove this link until and unless upper path is up. And when upper path will goes down, then you can again plug this link. This way we can avoid the loop, and same thing here STP protocol is doing. Until and unless your primary path is up, STP will unplug this link. And once upper link will goes down, primary link will goes down, it will plug this backup link. Right? So how STP is going to get loop free? So guys, there are some terminology of STP that you need to learn. First of all, to create loop free topology, STP protocol is going to select one switch is a master switch. That master switch is called root
Bridge switch.
What is root bridge? The master switch. One switch out of these two switches will become root bridge. Now question is which switch will become root bridge or full. So the switch with lower bridge ID will become lower bridge ID will become. Now question is again, what is bridge ID then? What is bridge ID, guys?
Priority plus least
Bridge
MAC
ID is
address.
combination of two things. Priority plus
MAC address. Least MAC address.
MAC. By default priority on all the switches is 3, 2, 7, 6, 8 or 7. 7. 3, 2, 7, 6, 7.
8.
Yes, you can say 8 because by default then 1 is there and PBST protocol is running, right? Okay, for an example, by default priority is 3, 7, 6, 8 on all the, and MAC address over here is, let's say A, MAC address over here is B. So bridge ID of switch 1 is going to be what? 3, 2, 7, 6, 8 plus A. Bridge ID of switch 2 is going to be 3, 2, 7, 6, 8 plus. So which switch has lower bridge ID?
Switch 1.
Switch 1. So switch 1 will become what?
Root bridge switch.
Now root bridge, switch 1 is going to control the RSTP. Right? Now what root bridge will do? Bridge is going to perform port election. Port election, right? And there are 3 types of port in STP. First one is DP, designated port. Second one is RP, put port. Third one is alternate, right? So a status of DP and RP is going to be, guys, forwarding, and a status of alternate port is going to be blocking. So the port whose role is going to be alternate will be in blocking state. From the blocking state, switch cannot forward the traffic, right? Now to understand the port election, you have to understand the message of there is only one message for you, that is called B, that is called BP, right? BPDU is similar like hello message of OSPF, hello message of EIGRP. In the same way, STP also sends hello message, and that hello message is called,
BPDU.
guys, in the BPDU there will be some information, contents of BPDU, contents of, what will be the information? First thing is this ID. You already know ID. Bridge ID will be there and root bridge ID will be. What is the root bridge ID? ID. ID. Second one is sender bridge ID. Who is sending this? BPDU. Third thing is going to be cost. Third thing is cost. What is cost? Cost is nothing but the inversely proportional to bandwidth. Cost is inversely proportional to bandwidth of, cost is inversely proportional to bandwidth of link, right? So on the fast Ethernet link, cost is going to be different. On Ethernet link, cost is going to be. Now STP never reveal the formula to calculate the cost. So what we can do here, we can just remember the cost value on different types of link. What is the cost on fast Ethernet link? What is the cost on Ethernet link? Okay. So what is the cost on Ethernet link?
No, 100.
Cost on
100.
Ethernet link 100. Cost on
Okay.
fast Ethernet link
19.
19. So you can see the bandwidth of fast Ethernet link is 100 Mbps. Bandwidth of Ethernet link is 10 Mbps. So if bandwidth is less than cost value is large, if bandwidth is large than cost value is, so cost is something which is inversely proportional to link, and root bridge always generate BPDU with cost 0. So your switch will always generate BPDU message with cost. Then what will be the information? Port ID. Port ID will be here. Port ID. Port ID. So these are the information inside the BPDU, inside the hello message of. Just 1 minute. Hello. So guys, in STP, the most important thing that you need to learn is creating loop-free topology. And to create loop-free topology, what you need to learn? The port election. How STP is going to elect the okay. Okay.
Yes.
Yes, sir.
Here. So see, which one is my root bridge switch? Right? It will generate how many BPDU? 2 BPDU. One for each interface. In this BPDU root bridge ID 32768 plus A. Sender bridge ID is also going to be same 32768 plus A. Cost is going to be 0, what I told you. Root bridge always generate BPDU with cost 0. By default port parity is 128. Right? So port parity is also combination of two things. Port parity plus port ID. Right? So port parity over here is going to be 128 dot, right? 128.1. Over here in this BPDU on the lower link, bridge ID is going to be same 32768 plus A. Sender bridge ID is also going to be same 32768 plus A. Cost is going to be also 0 and port parity is going to be 128.2. When switch 2 will receive it, one more thing here I want to include, which is all the ports of root bridge is going to be, guys, what?
Designated port.
DP. Why? Because the definition of DP port is nothing but the port which transmit the superior BPD. Superior or best, both are same. Either I can say superior or I can say best or I can say lowest. Both are same. The meaning of both are same. Right? So if let's say switch 2 have also the BPDU, and if I will ask you that which switch is generating the superior BPDU, best BPDU, would be, right? Because the bridge ID is lower than the BPDU of switch 2. So switch 1 is generating superior BPDU, and from the all interfaces of switch root bridge switch, superior BPDU will be transmitted. So both ports will become what? DP. And you know the status of DP port is forwarding. Correct? Now see the definition of RP port. Is the port which receives the superior BPDU is called RP. The port which receives superior BPDU is called RP port. And on one switch there can be only one RP. There can be only one RP on the switch. On one non-root bridge switch there can be only one RP. There cannot be more than one RP. If there are two RP, two root port, that means again there is loop. Right? RP port is the port from which switch is going to forward the traffic. So on one non-root bridge switch there should be only one RP to avoid the loop, to create the loop-free topology. So either this port or this port will become RP. Now you need to identify which port is receiving best BPDU, superior BPDU. The port which is receiving superior BPDU will become RP. So compare both the BPDU and tell me which BPDU is the superior. Root bridge ID is same, sender bridge ID is same, cost is same, then it is going to check what? Sender port ID. Sender port ID over here is 128.1, sender port ID over here is 128.2. That means this BPDU is the best BPDU, superior BPDU, yes or no?
Yes,
That
yes,
means
sir.
switch 2 is receiving superior BPDU on this port, so this port will become what? RP. Now can this port become RP? No. And guys, on one link there can be only one DP. There cannot be more than one DP. So see on this link, DP is already there, yes or no?
Yes, sir.
RP is already there on switch number 2. That means this port will become what?
Alternate, alternative port.
Alternate only. This port will become alternate port. And status of RP is forwarding and status of alternate port is blocking. Right? So this is my loop free topology. Switch 1, switch 2 and port 1, port. If this link will goes down, what will happen? Switch 2 will stop receiving BPDU over here. So this BPDU will become best BPDU. This port will become RP. Right? So when this primary link will goes down, lower link will become best. Clear? This is how STP is going to calculate loop free topology. How STP is going to create loop free. In this case, can you tell me what is loop free topology? Here I am going to write MAC address 0A or A MAC address. Here MAC address is B. Here MAC address is C. Tell me what is loop free topology? Where we have link port number 1, port number 2, port number 1, port number 2, port number 1. Which switch will become root bridge, guys? Which one?
Yeah.
Root bridge. So all the ports of root bridge will become what? DP. This port is DP.
DP.
This port is also
DP.
DP, which is receiving superior BPDU over here. This port will become RP. This port will become also RP. RP, right? Now on this link we cannot have RP because RP is already there on both switches. Now what we need to find here? DP. What we need to find over here on this link? DP. So which port will become DP? This port or this port? You need to check which switch is sending superior BPDU over here.
On the
Am I audible?
Yes, sir.
Because guys, in the BPDU of switch 2, root bridge ID is going to be same. In the BPDU of switch 3 also root bridge ID is going to be same. Cost will be what? The receiving interface cost 1919. If this is fast Ethernet link, then it is going to check.
One doubt. Second, we need to check sender bridge ID only. But
Yes.
you have checking
Cost is
cost.
same, root bridge ID is same, but sender bridge ID is different. Right? Before cost, it will check what?
Sender bridge ID.
Sender bridge ID. So sender bridge ID of switch 2 is 32768 plus B. Here it is C. That means this switch is sending superior BPDU. This port will become DP and this port will become alternate. So my loop free topology is this one. Yes or no?
Sir, could you please repeat one more time?
What I am saying, switch 2 is sending superior BPDU on this link. So this port is DP and this RP is already there. On this link DP is already there, so this port will become only alternate. So my loop free topology is this one. Here I have one link, here I have one link. I don't have any link over here.
Yes,
This
sir.
is my loop free topology. If I am going to create one another topology here, in this topology you can find the loop free topology. This is real time scenario because in real time this is how we are connecting the switches, correct? Here of all you need to find RP, root port, right? So on this switch, which port will become RP? Here also it is receiving BPDU, here also it is one.
No, now it's okay.
okay now? Is it okay now?
Yes, sir. Okay.
Yes.
Yeah.
So in all the BPDO on switch number 2, guys, sender base ID and root base ID is going to be same. So switch is going to check what? Cost. Cost over here will be 1919. Cost over here is 3838. Cost over here is also 3838. Now switch 2 can understand that I am receiving superior BPDO on one port out of these 2 ports on the basis of cost. These are inferior BPDO, yes or no?
Yes.
Manan, your mic is on.
MAC address is, guys, if I will get noise from your side, then I will disconnect the class. Okay? So make sure if there is noise, you will keep yourself on unmute. If you have any question, then unmute yourself and speak. Okay? Now I have another scenario like this. Switch, then here I have one hub. And then I have 2 link here. Switch number. Switch 1, switch 2, MAC address is B. So in this case, which switch will become root bridge? Again this switch, root bridge, because this switch have lower MAC address. This port will become DP. Now here which port will become RP? Port number 1, port number 2. Which port will become RP? See, sender base ID in both the BPDO is same, root base ID is same, cost is same, and sender port ID is also same. So guys, if sender port ID is also same, then switch is going to check receiving port ID, right? Which is not coming in the BPDO. Switch will check there on receiving interface port ID. So receiving port ID of this port is lower than this port. So this port will become RP. This port will become alt. Clear?
Yes, sir. Clear.
Right? There are some more concepts in the STP you can go through by reading your. Okay. So in this case here I need to implement STP. What will be your requirement while implementing the STP in real time? Here your requirement will be switch 1 should be my bridge. Switch 1 should be my root bridge. Or sometime your requirement will be switch 1 should be my primary root bridge. And switch 2 should be my secondary root bridge. If primary will goes down, then secondary switch should become bridge. But by default, any switch can become root bridge. Switch with lower MAC address will become root bridge. So you are going to control the root bridge first of all. The second thing which you are going to calculate is control is path. In this case, for an example, in this scenario, in this 3-tier architecture, here I am running STP. Here I am running STP, right? Or this one, let me let's say 1, 2, switch 3. Here MAC address A, here MAC address B, here MAC address C. So this port is DP, this port is DP, this port is RP, this port is RP, this port is DP, and this port is alternate. My loop free topology is this. Am I right? Now your requirement is different. You need to create this loop free topology. How to create? How to create this loop free topology here? Guys, I can increase some cost here. If I will configure cost 500 over here, then automatically this port will become what? Alternate
port.
Right? Because now switch 3 is receiving superior BPD over here with cost. Here cost 500. So this port is the best port to reach. Right? So two things you need to manipulate in the real-time network: root bridge and path. To configure root bridge, here I can run one command on distribution switch 1. So spanning tree protocol. So a spanning tree protocol is running here, and all the ports of this switch is DP, because this switch is the, and here you can see the priority and address 32768 plus LAN ID, because actually PVST is running here. So a spanning tree summary, you can see which protocol is running, which is in PVST mode. So PVST is also one type of STP.
Will you teach this PVST?
In CCNP, I will teach you.
RSTP, will
Yes,
you teach
RSTP also.
CCNP or CCNA? RSTP.
RSTP is also part of STP. There are multiple types of spanning tree protocol. First one is common spanning tree protocol, which is STP, which we have discussed. This is common spanning tree protocol. We are saying CST. CST, common spanning tree protocol. Second one is PVST. Guys, there is no any difference in CST and PVST if we have only one VLAN on the switch. If we have multiple VLAN, then for each VLAN, a spanning tree protocol is going to run one instance. Right? So let's say on the switch I have created two VLAN. Right? So two CST is running there. That is the only difference. But there are some issue with convergence of PBST and CST. So that's why we come up with RS. Then Cisco come up with RPVST. And we have last one that is called MST. These are the types of spanning tree protocol. But in the implementation, what we need to learn here? The configuration. What I told you, distribution switch 1 should be my primary switch. So here we can say a spanning tree for VLAN, for any VLAN, and here is the breeze option. Please work. Root and primary or second. So this switch should be my primary switch. I am going to configure primary over here. Once I will configure primary, see what will happen. Do so spanning tree. Earlier priority was what? 32768, and now see priority is what? So what it did, guys? See here, earlier priority was 32769 minus 24577. So it have reduced this priority once I have configured primary. And once I will configure secondary on the switch, like on switch number 2, spanning tree for VLAN 1. And why I am selecting the VLAN? Because PVST is running, right? For each VLAN we are running different instance of STP. Then one root, and then I am going to say second. Now do so entry. Again it will decrement in priority only. Priority over here is 2 4 5 double session 7. Priority over here is also same. That means there is a root. That means there is no connectivity one and switch. Okay, here is the bridge information. Here is the bridge. This switch is not root bridge. One is the root bridge because switch one have lower priority. Eight one nine have decreased priority by which did have decremented in priority by 4096, right? So once we will configure secondary keyword, which is going to decrement in priority by 4096. 4096. When you are going to configure primary, then it will decrement in priority 32769 by 24566 by 819. Okay, 4 multiple. Priority is increment in 4096. 4096. Priority will be always incremented in. Cannot configure priority 10. Either you can configure 0 or you can configure 0 or you can configure 4096 or you can configure 4096 plus 4096, right? It is going to be
9-2.
right? So priority on primary switch is 8092 and priority on secondary switch is lower than that, sorry, higher than that. So switch 1 is now my primary switch. If the primary switch will goes down, then automatically secondary switch will become. One more thing is happening over here. STP, by default STP is running on all the ports, on all the ports of switch. So access layer switches are sending BPDU from this port also, from these ports also, but get this port does not require STP messages, yes or no?
No.
So here we can configure what? Port fast to stop. Port fast is another feature, it is not to stop beep. We can configure edge port, right? We can tell to STP that these are the edge port, then STP will not send any messages on this edge port. So if you have configured these all ports as static access, then even you don't need to define the port number. We can say edge default. So this command will stop sending STP message from all the static access port, not on dynamic auto port or dynamic desirable port or trunk port, only on a static access. Or you can enable it on the port also manually. And STP takes 30 seconds to come in forwarding state just because of their behavior, right? In STP there are some states. Those states take 30 seconds to come in forwarding state, but I don't want to wait for 30 seconds whenever change will occur in the topology. That's why we can enable port fast on all the access ports so that my access ports can come in forwarding state quickly. So on the access switches we need to run two more commands on all the access switches. Which command? Enable config tree. First one is a spanning tree. Spanning tree for VLAN 1. This is not the command. interface is so this is on interface, and in global mode you can say a spanning tree, port fast, then edge default. So this command will stop sending message from access port, from the all static access port. See the warning. This command enable port fast by default on all interfaces. You should not disable port fast. अगर जैसे if you have enabled port fast on trunk link, then you have to manually disable it. Okay, it can cause the temporary. So this command is required on all the access switches. On the distribution switch, primary and secondary command is required. Then if you want to manipulate the path, you can configure the cost and those options. Like between access switch 1, distribution switch 1 and access switch 1. If here I have one link, then guys again loop, this is the loop. So STP is going to block any port. This port will be always DP, this port will be also DP, this port will be RP, this port can be the RP port, and this port is going to be alternate. But if you want to make this port is a RP port, here you can increase the, so that kind of manipulation. Now between distribution switch 1 and distribution switch 2, you can see I have two links. So STP will only allow one link. Am I right? STP will only allow one link to be in forwarding state. How we can verify? I can verify it on distribution switch 2. Here I can run command show spanning tree. You can see 1/0 and 1/3. 1/0 is the alternate port, and 1/3 is the port. Getting my point? So I am only using one link between distribution switch 1 and distribution switch 2. If you want to utilize both the link, see, I am looking for any solution who can avoid the loop also between switches and can provide redundancy also. How I can utilize both the link between switch 1 and switch 2? By disabling STP. But if I will disable the STP, loop will form. Am I right? If I will disable the STP, then loop will form. So I need loop free topology also. There are two requirements. First one is I need loop free topology. Means I don't want to disable STP. Second thing, I need redundancy as well. I want to use redundant path also. Use both link. So in this case, we have another technology called EtherChannel. Right? So what is EtherChannel? It is an technology which is used to bundle multiple physical links into single logical, right? And after bundling these two links, let's say I have bundled, combine it, then where STP will work? STP will work over port channel, right? So let's say this is my virtual link between switch 1 and switch 2. P1, here the interface name is 1, here also interface name is. So now STP will not work on this physical link. STP will work over this logical link. Then again you can say, Praful, if STP is working on this logical link, then again loop can form because there are two physical links. But no guys, see what will happen now. Now when this user will generate broadcast message, all F message to switch, switch is going to forward it from both the link, both the link. But even there are some advanced concept in ether channel, it will not forward from the both the link. It will, there are various type of load balancing algorithm in ether channel, like source MAC load balancing, source IP load balancing, source IP, destination IP, source and source MAC and source IP, source destination MAC and destination IP load balancing. So these are different types of load balancing algorithm with ether channel. According to that, it will decide from which port I need to forward this. But even though if it is forwarding from both port, then when switch 2 will receive the broadcast message on this port, it will check. I am receiving a broadcast message on interface ID 1 on interface 1, which is part of port channel 1. So I will not forward this broadcast message from any other interface which is part of same port channel, which is part of same port channel. So port number 2 is also part of port channel 1 only, right? So switch 2 will not forward this broadcast message from this port now. So this way we can avoid the loop here. Okay, so here if I will talk about the implementation, so in implementation we need to implement ether channel between switch 1 and switch 2. Again guys, like DTP, like VTP, we have two methods in ether channel. Either we can form ether channel between switches manually or dynamically. In manual method, we are going to configure on mode on both switch. On mode on both switches we are going to configure on. So there are some modes in the ether channel which will define which type of ether channel you are using. If I will talk about the dynamic method, so definitely I need protocol. So we have two protocol. First one is and second one is
LACP.
right? So PAGP is an Cisco proprietary protocol and LACP is an open standard protocol. Okay, on Cisco devices you can configure PAGP, on other vendor devices you can configure, on Cisco devices you can. Mode over here in PAGP is, again there are two mode: desirable and auto. Desirable is similar like dynamic desirable in DTP, which can initiate the trunking. Here desirable can initiate the ether channel and auto can always wait. Means auto and auto cannot form ether channel. Desirable and desirable can form ether channel, right? Desirable and desirable can form trunking, correct?
Yes, sir.
Auto and auto cannot form trunking. The same way here, if one side here I have configured mode what? Desirable. And other side I have configured auto, then ether channel will come up. But if both side mode is auto and auto only, ether channel will. Desirable, auto desirable or desirable auto can form ether channel. And in the same way in LACP we have again two mode, active and
Passive.
right? Active is similar like desirable and passive is similar like. So active can form ether channel, active passive can also form ether channel, but passive cannot form ether channel. So any method here we can use to configure ether channel between switches. Tell me which method you want. And guys, when you will go for CCNA and CCNP, then you are going to learn layer 3 ether channel also. This is layer 2 ether channel. Layer 3 ether channel is also there. Means if we need to perform routing between switch 1 and switch 2, so we can configure, we can make this port, virtual port, logical port as layer 3, then we can configure IP address, and then we can configure routing protocol there, right? Those are again the advanced concept we are not going to cover here for now. Okay, let me implement EtherChannel. Tell me which method you want to use, a static method or any protocol.
Yeah, protocol.
Which protocol?
No, sir, before considering this, I have one question. Sir, spanning tree protocol election, first root bridge ID will be checked. Next, cost or center bridge ID. Second check will be what? Cost or center bridge ID.
No, there will be not any election for cost. There is no any election. There are only two types of election. One is root bridge election and another type of election is port election. That's it.
Then when the cost will be checked?
When switch will receive the BPDU, then it will check cost to identify the superior BPDU, to identify the best BPDU. Let's
Yeah.
say you are getting BPDU from two sides. So you will identify now which BPDU is the superior, which is the best. For that you are going to check cost.
Yeah, my question is first it will check the root bridge ID or cost.
First it will check root bridge ID, then sender bridge ID, then cost, then sender port ID.
Okay, okay.
The sequence is first bridge ID, then sender, bridge ID, then cost, and after that sender port. If sender port ID is also same, then receiving port. Okay, brother. The sequence.
Yes. Yes, sir.
So let me form ether channel over here between distribution switch 1 and distribution switch. To verify the ether channel, you can check so interface. So IP interface brief also you can use so IP interface brief command. So there is no any virtual port here you can see. So interface status you can check. So interface status. There is no any virtual interface. You can check so ether channel. So ether channel summary command you can use. You can see there is no any ether channel configuration. Now let me bundle. Now STP is running on both the ports. After configuring ether channel, STP will work on port channel. So interface E1/0. First of all, I am going to set the port and then I am going to say what? Channel group. Then channel group. Number, let's say 1 or 10, any value you can use, and then mode. Right? So if you want to enable LACP protocol, either you can use active mode or passive mode. If you want to enable PAGP, you can configure desirable mode or auto mode. And if you want to configure statically ether channel, then you can use. Okay, so on mode will enable ether channel only. Active mode enable LACP unconditionally. Unconditionally means it will form the ether channel. Right? This mode, auto mode, enable PAGP only a PAGP device is detected. If the other side you have configured the desirable, then only it can form the right, and desirable mode is again going to turn on PAGP unconditional. Clear? So here for an example I am going to use mode, let's say desirable. That's it. Then another interface E1/1. Here also I am going to set the port and channel group. Number was 10. Make sure both belongs to same channel group. Group and mode. Here also I am saying. Done. So interface status. You can see port channel is created. but now this port is not connected, unassigned. Why? Because guys, these ports are, you can say, disabled. Ports are not disabled, shut down. Let me take a distribution switch 2, and here also I am going to create port channel. Interface 150, interface range E1/0 and E1/3. Shut down. Then channel group number, here you can use 10 or 20. This is locally significant to switch, so I can say 10. Then mode should be what here? Auto. Mode can be auto. And now I am going to run no shut command on the port. Interface range E1/0, then say no. Go to switch number 1 also, and here also. Interface range E1/0/1. Now again you can check show interface status, and now your port channel is up. Port channel is okay. On switch number 2 also, so interface status, port channel is. You can run this command also, so IP interface brief. Here also you can. Port is not assigned, we have not configured any IP addresses here, but ports are. So EtherChannel summary, by using this command we can check the ports, port channel configuration, the group number, which type of EtherChannel you have configured, L2 EtherChannel or L3 EtherChannel, which protocol you have used. All these informations are. Then we can also check the interfaces, so EtherChannel, and then we can say detail. This is also one command. Check the detail information. Check the detail information, then show EtherChannel. The mark C, multiple port option is there. We can check port. Channel group 10. These are the ports 1/0 and 1/1. Okay. Mode and group number, everything you check here. Then there should be one more command for that. Load balancing algorithm, you can sync summary. Here is the, in summary you can see ports are also there, right? So these two ports are part of the channel. Now guys, let's make communication possible between departments. Okay, now we have implemented the switching protocols over here. Now we are going to do what? We are going to now make reachability between multiple. So you know the gateway is required. On PC1 what it's saying, no gateway found, so gateway is required. What I'm going to do, I'm going to create SVI on distribution switch 1 and 2. On distribution switch 1 you can see my SVI are here. On switch number 2, this one. The last IP address from the subnet I am using as a gateway on distribution switch 1, and the second last IP address from all the subnet is gateway on switch 2. Okay, so let me create these SVI. Create the SVI, I am going to use notepad here. Can anyone tell me the command? Interface VLAN 10, no shut down, and IP address. IP address is 192.168.1.2.4 255 dot, like this for VLAN 20, for 30, for VLAN 40. Let me make it 20, and here I am going to what 2.254 and 30 interface. I am going to configure what 3.254 30 interface. I am going to configure what 4.250. Copy it. Done. Now let me take you to that on this switch 2. IP is going to be, guys, 253. 3 3. Are you getting me?
Sir, I think the VLAN 30 is two times implemented.
Oh, it is VLAN 40. 40 or one
Sir,
interface.
IP address, sir. IP address. Correct the IP address on VLAN 40.
IP address 192.4.255.5.0. So IP interface brief. VLAN 40 is down. Interface VLAN 40, no, shutdown. And now you can check. All the SBIs are, guys, up here. All the SBI interfaces are up. Right? Now let me copy this command. Paste it on distribution switch. All the commands are accepted. So IP interface, you can see all the SBIs are. Now I am going to verify first reachability between switch 1 and switch. Here should be reachability. Switch 1 should be able to ping switch 2. Ping 192.168.1.253, and I am going to say source 192.168.1.250. Sorry, 2. Oh, yeah, 250. I am going to ping 53 now. 2 IP address from 250. And this ping should work, and you can see ping is working. Right? So that means there is reachability. And guys, how ping is working? Through which link I am able to ping switch to? Through EtherChannel or via access port?
Through the EtherChannel.
Through the EtherChannel. Through the EtherChannel. What about others? So, VLAN brief. This is an interview question. So, a spanning tree, here you can verify. Now you can see STP is running on port channel 10. STP is not running on 1/0 and 1/1. Okay. And through EtherChannel, there is, if there is no link between switch 1 and switch 2, then it is going to communicate via access switch. So this is the reason why EtherChannel is important over here. Now what will be the gateway on PC1? What will be the gateway?
1.254.
If I am going to configure 1.254, then guys, all the traffic will go via distribution switch 1, and when distribution switch 1 will goes down, then I have to change the default gateway IP address.
Yes, sir.
Right? So at
We have
this
to
moment
implement
of time, another protocol comes in picture called
HSRP.
FHRP. First hop redundancy protocol. Right? Now we are looking for redundancy for first hop. For the first hop means what? First hop means right? So there are three protocols under first hop redundancy protocol. First one is HSRP, second one is VRRP, and third one is GLBP. These all protocols are used to is used to create a virtual IP address by combining multiple physical IP. For an example, router 1, router 2, ISP 1, and ISP, and here is the and here is my LAN user. Here is my LAN user. Here IP address is, let's say, 10.1.1. Here IP address is 10.1.2. And on the PC, my IP address is 10.1.1. So if I am going to configure default gateway here .1, all the traffic will go via router 1. If I am going to configure .2, all the traffic will go via router 2. And whenever any router will goes down, then manually I have to change the gateway, right? Agree?
Yes, sir.
And to avoid this issue, what we are doing with the help of HSRP protocol, we are going to create one virtual IP address by combining these address. Let's say my virtual IP address is 10.1.1. And I am going to configure this IP address as a gateway IP address on the PC. 10.1.1. So what will happen now? The protocol is going to decide which router will be the active router. One router will be, guys, active router here, and one router is going to be standby router. Standby router, right, which will be in the standby mode. So for an example, R1 is my active router, R2 is the standby router. But your PC is forwarding traffic to whom?
R1.
To .200. So if
Yes.
PC need to access internet, first of all your PC will generate ARP request to resolve the MAC address of default gateway, and active router will share their MAC address. Active router will share their MAC address. Okay, so all the traffic will go via router number 1. Once router 1 will goes down, R2 will become active router automatic, right? And guys, to check that R1 is still alive or not, both routers are going to exchange hello message. So if there is no reachability between router 1 and router 2 via switch, then both router will become what? Active, right? Then both router will become active. So this is also one interview question. Sometimes they can ask you, like in HSRP, both the routers are showing active. What can be the issue? You can say there is no reachability, sir. Now, which router will become active router? The router with higher priority. Router with higher priority. Okay. So routers are going to share priority information in their hello
Higher
message.
priority, how, which will be the higher priority? Highest IP address or
No,
any other?
HSRP priority or VRRP priority or GLBP priority. In STP we have priority, guys. Priority on each switch 32768. What is the use of that priority? That priority is used to elect root bridge. In the same way, we'll have priority in HSRP. which is used to elect active router. Router with higher priority will become active router, right? And how router 2 will get to know about the priority of router 1, and how router 1 will get to know about the priority of router 2. Both are going to share in the hello message. But by default, if we are not going to configure priority, then priority is going to be same. Then router with highest IP address will become active router. Okay, so by default R2 will become active router. If you want R1 should be your active router, then you can configure here higher priority. Clear?
Yes, sir.
Let me create the virtual IP address now. Config T, interface, VLAN 10. Here I am going to say standby, then group number, and then IP address, the virtual IP address. Right? For an example, 192.168.1.100 is the virtual IP address over here. Okay, and same command I will run on router number 2 also. Sorry, on like distribution switch 2 also. Config T, interface VLAN 10, standby group number 10, and IP 192.168.1.100. Right? Now which router will become active according to you? Which switch will become active switch? Priority is same. Priority is same. Then it will check IP address. Router with highest IP address will become active. So router 2 means switch 2 should become active. But so standby. This is the verification command. This router is, guys, active router, right? Why this router is active router? What is by default priority? What is default priority?
100.
Right? Because you know why router 1 is active router? Because whenever a router will come up, it will wait for a particular time. Within that timer, if router will receive hello message with higher priority, then only that router will become active router. But if a router is not receiving any hello message with higher priority, then router will declare themselves as active router. And once one router will become active, doesn't matter that the router have higher priority or lower priority, they cannot become active. Yes, end by. Right? Even you want to disable this feature. If you want that whenever a router is coming with higher priority, that router should become active, then you can enable this feature called preemption by default, which is okay. So to enable the preemption, here I am going to run one more command. Interface VLAN 10, standby group number 10 preempt. On switch number 2 also I am going to enable. Interface VLAN 10, standby group number 10.
So, sir, this preemption only disable for VLAN 10.
Now I have only configured HSRP for VLAN 10. I did not configure HSRP for VLAN 20 for now. We'll do the configuration
Okay.
for all the VLAN. Now we can again verify the standby. So standby. Which switch is the active switch, guys? Now you can see this switch is in listening state. Wait for some time. And on switch number 2, so this switch is my
Active switch.
and some more informations are there. You can see like this switch is the active switch, last state change, the virtual IP address, right? The active virtual MAC address, the local MAC address, hello time, hold on time, 3 seconds, 3 seconds, preemption is enable or disable, which router is the active router, local router, right? If R1 is the any another router is the active router, then you will get the IP address of that router here. Standby is unknown. Now I think router 2 become standby. So now you will not get unknown here. Now you can see standby router is 192.168.1.54 where priority is on router number 1. Check active router IP address is
Hello? Hello?
clear guys. आ रहा है समझ में? कैसे ही जा रहा है क्लास?
नहीं सर, आ रहा है समझ में।
यही है एक्चुअल इम्प्लीमेंट। बाद में आप वीडियो के थ्रू जाना है ना?
हाँ सर।
In this way only we need to configure HSRP for rest all the and here IP address dot 250 dot IP is and for 30 and copy it on which one done. Now for all the VLANs, which switch will become active switch? So standby and by CP junction is only enabled for only enable preemption for all within I mean for all the sense what I am expecting switch 2 should. Bye. See, so you can do one thing here. You can turn off the interface and then like set the interface and no set the interface once. That in the simulation only it's a interface change VLAN can and and 30 and set now switch. Course set one have the higher IP address na one have the higher IP na then switch
Yeah,
one should be only active router for all the VLAN. Why switch to active router for VLAN 10? Active switch VLAN. Everything is fine here. Might be possible this is in simulation. Switch 1 is going to be active switch for all the VLANs. So standby brief. Let me go to interface VLAN 10, say shutdown, and then no shutdown once. In simulation, sometime it is giving the wrong output. So standby brief. By is switch what the face VLAN 10 shutdown. No shut. One should be my active switch for all the. Now I am checking for VLAN 10. Standby is still unknown. Yes, now you can see the correct output. Okay, for all the VLAN on switch number 1 you can see active router is local. Now guys, if I want switch 2 should be my active VLAN for VLAN 30 and 40. Here I want to perform load balancing. Before load balancing, now I can show you one thing. From the PC1, now I can ping to PC3. Here gateway is required. Say IP 192.168.1.1/24 and gateway 192.168.1.100. Then on PC number 3 also have to configure gateway IP 3.3 and gateway is 192.168.100. Right? Now two different VLAN can communicate. Ping 192.168.3. And you can see ping is working. So now all the departments are able to communicate with each other, correct? Now they can reach to internet also after configuring this section. But guys, all the users will reach to internet or they will communicate, two department will communicate via switch number 1 only. If switch 1 will goes down, then switch 2 will become active and they will start communicating via switch number 2. Now I want to perform load balancing here. What I want, for these two VLANs switch 1 should be the active and for these two VLANs switch 2 should be active. Right? Means for lower 2 VLAN this switch should be a standby. For lower 2 VLAN, here for upper 2 VLAN this switch should be a standby. But in case of failure, if this switch will goes down, then this switch should be active switch for all the VLAN, or if this switch will goes down, then this switch should be the active switch for all the VLAN. So what we can do, we can increase some priority over here for VLAN 10 and 20 so that this switch will become active for 10 and 20, and then we'll increase some priority for VLAN 30 and 40 on this switch. Getting my point? Interface range VLAN 10 and VLAN 20. Here I can say what? Standby group number 10 and I am going to say priority, let's say 110. And on switch number 2, interface range VLAN 30 and VLAN 40. Standby group number 10 and here I am going to configure priority 11 G. Right. So now you can see this switch is active for VLAN 10 and 20, 30 and 40. So standby brief. For VLAN 30 and 40, this switch is the active switch, local switch is the active switch. And for VLAN 10 and 20, so standby brief. Is for these two VLAN, this switch is the active. Clear, guys?
Yes, sir.
So this is your routing, switching section in the production environment. Now here routing comes in picture. Now how we can advertise these all LAN prefixes to router, core router, by configuring routing protocol here, right? So first of all, let me make some port like Ethernet 1/2 as layer 3 port, because here we are going to configure IP, correct? Config T interface E1/2. What I will do here, configure switch port or no switch port, no switch port. Now this port is layer 3 port. Here I can configure IP address now. Now here I can configure IP address. So I am leaving this part for you guys. You guys can configure the OSPF over here. Can make reachability between distribution layer switch and core layer router. And after that I will come to this section where we'll see the netting configuration. So you tell me, can I continue this portion now, or you need this section configuration in next class?
For next class, it will be good because in one day, all the configurations getting understand is tough.
Okay. So today we have seen the switching topics. Whatever topics I have covered in switching, make sure you will read the book, right? There are some more concepts also, you will cover that by yourself. You can watch the videos on YouTube as well, right? It doesn't matter how you are learning. And after that you will configure it by yourself also. Until and unless you will not implement it, it will be difficult for you to understand the concept. Okay?
Sir, can we configure this same lab on packet tracer?
Yes, in packet tracer also you can configure.
And sir, this video is on YouTube live video, na?
Yes, it's live
Okay.
on YouTube from there.
Okay. So we can watch this video one or two time, and then we get
Why
understand all.
1 to 2 time, brother? Why you
Not
need to
all
watch
the
the
video.
videos? Tell me first.
Hmm?
While configuring, you can watch the video to check
Yeah,
the
yeah.
commands.
Yes, sir. These things.
You should
Just to
have
check the
the
comments.
logic about the protocols. Why I have configured the STP? Why I have configured the EtherChannel? Why I have configured the HSRP protocol? What is FHRP? What is EtherChannel? So you should know the logic, like what it is. What I told you in CCNA, you are learning what, right? So you can make one small notes for these all topics. You can write the small definition. Whenever interviewer is going to ask you, you can answer them.
Sir, if the interviewer asks what is HSRP, then we can say like
It is used.
company. Uh,
It is used
yes,
to
sir. Yes, sir.
create a virtual IP address through
That's
multiple
what.
physical IP address to
Yes.
get redundancy for first hop.
Okay. This HSRP will be covered in CCNA or CCNP.
In CCNA also you are going to learn the basic HSRP, like what it is. See, now in HSRP there are many more things. Like guys, here I have configured the HSRP. Done. Enable the HSRP between switch 1 and switch 2. Let's say this switch is my active switch. What if this link will goes down? Right? So gateway is this one, and this gateway will be dropping the traffic. Forget about this link. Let's say this is not available. There is only one link. So what if this one link will goes down? Can user access internet? No. So in HSRP you are going to learn tracking also in CCNP. How we are going to track this link? How we are going to track the ISP? So until and unless ISP is reachable from this switch, then only this switch is going to be active switch. If this link will goes down, automatically switch 2 should be active switch. So these kind of failovers are there in the CCNP that you can learn there. But if you have the fundamental knowledge, you can learn it by yourself also, brother.
Yes, sir.
Here is one server. You can set up this server for DHCP so that these end devices can get IP address from DHCP server. How many of you know the DHCP configuration on Cisco router? Here what I can do, I can create one pool for VLANs, for all the VLANs. Let's say IP DHCP pool. I'm saying VLAN 10, right? Then I am going to define the network 192.168.1.0 mask 255.255.255.0 and default router IP address is 192.168.1.100, which is my virtual IP address, right? In the same
Yes.
way for VLAN 20 also I can create the pool where my network command gateway IP address is going to be 2.100 and network command I am going to use here 2.0 dot, right? Then for VLAN 30, for VLAN 40, then I can exclude some address IP DHCP exclude address 192.168.1.254 I have already used on the router. Then 253 I have already used on another router on another distribution layer switch. Then .100 which is my virtual IP address, right? So I have excluded these three IP addresses. Now my end device can get IP from DHCP server also. Only one thing is required here on DHCP server, IP configuration. So config T interface F0/0 no cert IP address 192.168.1.44, let's say 4.4, 4.1 for an example, 255.255.0, say no IP routing to disable routing capability, and then say IP default gateway. What is default gateway IP? 192.168.4.100, right? And then finally on switch number 4 I need to place this server in VLAN 40. That's it. Enable config T interface E 0/3 switch port access VLAN 40, right? Now from the server I can try to ping my gateway first. Ping ping 192.168.4.100.
So you are on switch 4.
Ping 192.4.100 and see there is reachability, yes or no?
Yeah.
There is reachability. Now I can tell to my switch who is DHCP server. If you know the DHCP, guys, you can correlate these all things. Like here interface VLAN 10, I can say IP DHCP helper address. IP DHCP command is there. Information.
I think DHCP helper, IP DHCP helper, and then the address.
IPDACP hyphen helper.
And VLAN 10 user get IP address from DHCP. NPC1 get IP DHCP. Not possible, right? Because helper address is required. DHCP belongs to different subnet. On
Yes,
this
sir.
layers interface IPDH. DHCP. Mm, I think IP helper address on interface VLAN, then IP helper address, right? And the IP address of DHCP server 192.168.4.1. That's it. Now PC1 can get IP from DHCP server. Here say IP. Now you can see Dota process is working and this PC got the IP address. So this way, all the VLAN users can get IP from DHCP server. This is the actual implementation of your protocols. Here,
Yeah, yes, sir.
Sir, reminder, previous class recording, please.
yeah, I will see.
And sir, what is the tomorrow's class time?
Same.
From 2:30
So two
2 p.m. Okay.
Uh, Sir, class has ended or not?
yes, yes, class.
So we may go out.
Yes.
Okay, sir.